Okay, good morning, AS students. Okay, looking at Ka5, going to go through each question. You've got your Ka5 back, and today I will give you a copy of the mark scheme. I forgot to give it to you yesterday. And you've got follow-up questions to be working on. Okay, so this first question, it's quite wordy actually for a multiple choice question. So scan it, and if you can't see an immediate answer, I would move on. It's one mark. You can come back to it later when you've got time. But if you read each statement carefully, you will see that B is the correct answer because ionisation energies increase across a period. Intermolecular forces decrease from hydrogen fluoride to hydrogen chloride because of hydrogen bonding in hydrogen fluoride, but not hydrogen chloride. And that, that's a little bit deceptive. And again, here it's talking about the ability of halide ion to act as a reducing agent, which means it's oxidized. Actually increases from fluoride to iodide. Okay, so B is the correct answer. Question 2. Here you're obviously having to think about moving in a shell, really, to show a significant difference. So sodium's got 1 electron in its outer shell, magnesium's got 2, and then neon and argon obviously are both noble gases, so you can eliminate those two. If you get rid of sodium's outer electron, you're moving in closer to the nucleus, which means it's going to be much higher. That's where you get the big jump on the graph when we're looking at ionisation energy. Question 3. Why does the boiling point of the halogens increase down the group? Well, you should know that it's only London forces that are acting here, and that the bigger the molecule, the stronger the force. So nothing to do with covalent bond, nothing to do with bond polarity, because again that's to do with covalent bonding. And in terms of electronegativities, they actually decrease as you go down the group. So the only answer it could be is the surface area increases. Now, you might not have come across the term surface area, but you do know that if you've got a bigger surface area, then hopefully that will indicate to you you've got a bigger molecule. So you could go for that one, even if you didn't know that was the answer. That would be an educated guess. Okay, question 4. The first thing to do here, obviously, is to recognise that you're forming a chloride. So you need to know, the test for halides. Yeah. Once you recognise that it's a chloride, as it says here, it's straightforward to work out using the ratio 1:1 from the equation. Yeah. So again, a little bit, quite a long multiple choice question in that you've got to read all that information, then you've got to do a quick calculation. So I might be inclined to move on and come back to it, but that's up to you. As long as you're keeping an eye on the time in an exam, you have to do these things that are best for you. Which of the species is the best reducing agent? Again, what does that mean? It means losing an electron because it's being oxidized. So well, let's eliminate the molecules chlorine and iodine, and then think about group 7 and the size of the ion. Which one will lose its electron easier? Okay, and it's D, of course. Which one of the following is the electron arrangement the strongest reducing agent? Again, which one will lose its outer electron more easily? And in this case, the answer is D. It's, you can see that the electrons are further from the nucleus, so they're going to be easier to lose. Okay. Right, question 7. Right, so this one, you should, really this is the kind of thing you have to read up the history of the periodic table. You should be able to, just by looking at the periodic table anyway, you can look at the mass numbers to see which ones don't follow the correct sequence. It does say the first 20 elements, so you're only looking at the first 20 elements, and a number of you gave transition metals as the answer, which technically would have been correct, except that this question is asking about the first 20 elements. And you should know, without really having to think about this is a system 1 thing, that the modern periodic table is arranged in order of atomic number or proton number. Okay, part B, don't forget to write, to balance any equation that you write. So some of you kind of got the right symbols in there, but you hadn't balanced it. Metal with an acid, you know that you're going to get hydrogen gas, but how do you know that? What will you see? That's the crucial thing. It's asking you what you would see in this reaction. You would definitely see bubbles being given off, or effervescence, which is the kind of posh way of saying bubbles being given off. But you would also see the magnesium disappearing. Yeah. So don't forget to mention that, because there's 2 marks, so you need to make 2 points. And this is the idea of reactivity down a group. Does it increase or decrease? So if you've got the metal underneath, magnesium, then it's going to react faster. Okay, we're comparing here magnesium and chlorine, a metal and a non-metal. Yeah, structure and bonding, really common questions, and you can pick up quite a few marks as long as you answer these questions correctly. As it says here, 6 marks, 6 points you've got to make. So comment on the structure. One is a giant structure, one is a simple molecular lattice. Comment on the bonding type, so metallic bond that you're breaking in magnesium, but only an intermolecular force for chlorine, in this case London forces. And if you're talking about elements on the periodic table, they're always going to be London forces, the intermolecular force. Yeah, because you only get the dipole when you get 2 different elements bonded together, one with different electronegativity. And that's not the case if you're looking at an element. They're going to be the same atoms. So London forces between chlorine molecules. And then you finish up with a statement about more or less energy required to break bonds / London forces, depending on how you've approached the question. Make the correct statement about energy at the end. Okay. Part D. Oxidation numbers, yeah, 3 marks here, which pretty straightforward if you know the rules of assigning oxidation states. Yeah, if you can't do that, you've got to practice doing it. Learn the rules and practice questions on assigning oxidation states. So for your 3 marks, you have to say what's been oxidized, what's been reduced, and you have to give the 2 changes in oxidation number. Yeah, so you've got the mark scheme there. You can see what it says. Okay, so this is a little calculation, but it's slightly different in that it says calculate the volume of gas produced, and obviously a lot of you, I don't know whether you just went for the oxygen because you know that that's a gas, but if you look on the product side of this equation, there are 2 gases formed, which means you have to look at the number of total number of moles of gas formed, in this case 5 moles. And on the reactant side, your strontium nitrate, you've just got 2 moles, so you've got a ratio here of gas to the strontium nitrate of 5 to 2. Okay, so it's pretty straightforward calculation in terms of volume, as long as you've got the right equation, yeah, calculating volume of gas. But you've got to get the ratio correct. If you get that ratio wrong, you get the answer wrong. Okay, question 8. This is just a learning thing, learning the colours of the halides in cyclohexane or in water. You can't guess them, you just have to know them. Okay, ionic equation being asked for here. Yeah, so you've got to show some ions in it, which not all of you did. And also you need to make sure you balance it. Again, a number of you didn't balance it. Okay, so the last part of the question, I got an assortment of answers to this, but actually it's asking you to look at chlorine, bromine and iodine and what could you do to confirm what you found out previously. And if you look at the question, you haven't added bromine and iodine together or to iodide. So we're trying to see if bromine will displace the iodide ion. Yeah. So you have to mention bromine and iodide here. Okay, again, this is another oxidation number one. So, you know, if you're not sure about oxidation number rules, you will struggle with this question. And, you know, it's 3 marks and they are very straightforward marks if you know how to work out oxidation states. Give the 2 changes, yeah, and then answer the rest of the question, which a number of you didn't do. You gave the correct oxidation state changes, but you missed out on the last mark because you didn't explain how it showed disproportionation, which is what the question also asks. And this one about the public health aspect of using chlorine in water, read page 115 on the advantages and disadvantages to adding chlorine to water. Okay. Okay, so part C, you should know this from GCSE really. I don't think it's actually been covered in the AS, that if you break up a compound using heat, it's called thermal decomposition. You start with one thing and you end up with 2 or more things because you've heated it, and then that's called thermal decomposition. And then obviously here we're just looking at a straightforward volume equals number of moles times 24 to get volume. Yeah, your initial moles coming from mass over molar mass. This part of the question, as far as I'm aware, you don't actually need to answer to know this information. It doesn't hurt you to know it, but their thermal stability increases as you go down group 2, the carbonates. Okay. Right, question 9. Periodicity, the repeating patterns across the table. Okay. So again, you're going to have to think about what is the question asking you. There's 3 things that you will be expected to mention, and 2 of them will be actually relevant as such. So you're going to have to think about nuclear charge, is it increasing or decreasing? Atomic radius, is that increasing or decreasing? How does that affect the shielding of the nucleus by the electrons? So here for your 3 marks, you've got to point out that nuclear charge is increasing, atomic radius is decreasing, or if you said that the shielding is the same, you would have been allocated a mark, which leads to the fact that there is a greater attraction of the nucleus for the outer electrons, which explains quite clearly then why ionization energy increases as you go across a period. Okay. Explain the trend across the period. So don't forget to do the explanation. You give the reasons, the nuclear charge increasing, atomic radius decreasing, hence that leads to this greater attraction of the nucleus. So that gets you the 3rd mark. Okay. Yeah, this one, solid carbon exists in 2 forms, which is kind of, they've almost done this to put you off a little bit. You know, 2 forms, diamond and graphite. Yes, they do when they're solids. Explain why it is unnecessary to refer to carbon as either diamond or graphite in table 5.1. What does table 5.1 show you? It shows you ionization energy. Now, to calculate ionization energy, your element has to be in a gaseous state. We need atoms before we can ionize them. So it doesn't matter whether it's diamond or graphite. Basically, they're just carbon atoms that then become carbon ions. Yeah. So I think, I mean, you have the knowledge to answer this question, and most of you got this question wrong. And yes, it's only 1 mark, but it's 1 mark. It could push you up a grade, but also it can fail you. Yeah, you're 1 mark off, then you can end up with a U instead of an E. So think of it that way, and you know how to answer it. Okay, part B of this question. Now this really should have been pretty straightforward, but a number of you got part of this wrong. I mean, this was 6 marks, for crying out loud. Yeah, you should know that a diamond or carbon in the form of a diamond is a giant covalent structure. You should know that it's got covalent bonds between all the carbon atoms. Yeah. Fluorine, of course, is a molecule, and they don't have different electronegativities. If you've got 2 fluorine atoms joined together to form a molecule, so you're only going to have London forces between them. So very straightforward 3 answers there. Now here, the particles between which the force or bond is acting. I don't know why this seemed to cause more problems, like why you didn't seem to understand what it means by the particle between which the force or bond is acting. This metallic bond, the covalent bond, the London force, what is it acting between? Well, in a metallic bond, you have positive ions and delocalized electrons. In a giant covalent structure, which is in this case a diamond, which is made of carbon, you're going to have covalent bonds between carbon atoms. And here we've got London forces between molecules, and these are keywords, and you would have picked up 6 marks for having those keywords in the correct place. It says down here you must get terminology correct, and it's very important that you do. Okay, and then we're coming on to the last question now, question 10. Okay, first question, write down the formula of the positive ion and negative ion in the hydrated salt. Yeah. So XCl2, chlorine forms Cl -1 ion, hence X must be 2+. And you're just asked for the formula for the ion, so X2+, Cl-. A number of you, I don't know what you were writing, but you certainly didn't write the formula for the ion. And then the last part, balanced equation for the decomposition of the hydrated salt, and then use it to calculate the value of X to 1 decimal place. X is an element from the periodic table. It doesn't specifically tell us what X is, but on the mark scheme it did give you a mark for it, so I don't know. I think that maybe the question's not worded particularly well. But it wouldn't, if you know what X is, say it. Okay. So we're decomposing this compound here, yeah, into water and the anhydrous bit of the salt. Yeah. So once we know the mass, which we can work out from here, mass of water, yeah, we can work out the moles of water. Okay. Now if you look at this formula, XCl2 dot 2H2O, shows you that the ratio of water to the anhydrous salt is 2 to 1. So once you've worked out your moles of water, if you divide that by 2, it tells you how many moles of XCl2 you've got. Don't forget this ratio stuff. It's very important. You're using it all the time, whether you're looking at an equation or a formula. Okay, so we've got our moles of XCl2 now. So it's pretty straightforward to calculate the molar mass. Yeah, we take the above value that we've worked out, the moles. We have to take off 71 because we're looking for X. 71 obviously is the molar mass of 2 chlorine atoms. Yeah, so we need to take that away from the value that we've calculated here, which is of the whole salt, the molar mass of the whole salt, minus 71, which is our 2 chlorine atoms. Once we've got the molar mass, we can identify X, which, I'll quickly looking at the mark scheme, was barium. Okay, so I hope this has been helpful for you, and do lots of good revision over the Christmas break, and best of luck in your mock.